Well, this is the last lecture for our statistics class. It's going to involve two sections, 9.1 and 10.1. And some of it is going to feel like flashback from what we did in section 2.6, which was when we were doing linear regression. When we did linear regression, remember what we had? I've actually got it here as a recall. We had an equation that dealt with intercept and slope, where what we could do is, the slope would help us find, how often, how much a y value would increase for each x, and the intercept was, if x was zero, the intercept we would expect that to be our value. Now, since then, we have done hypothesis tests, and hypothesis tests we have learned that those involve a p-value, and a p-value is a nice way for us to check whether something was a fluke or not. And what we're going to do now is shift towards doing a test about the slope to see when we do get a slope, do we have evidence to show that that slope is actually significant, that there is an association between um, two variables. Now, what's different is that in 2.6, we denoted the intercept with an A and the slope with a B. And what's going to be different for 9 and 10, section 9.1 and 10.1, is we're going to use beta 1, as a way to have our notation for the slope. Now, here's what we're going to do. When it comes to HO and HA, the two different arguments, well, the null is going to be saying that the slope is zero. And so what that means is that, or another way we could say it, it's going to be arguing that there is no linear relationship between the two different variables. Like, that's one way to think about it. Is there's no linear relationship between the two quantitative variables. Now, what I thought might help is if I did a picture. And so remember, in 2.6, we had an x variable, and as that was increasing, we had a y value. And if there was a linear association, it was either that, things were increasing, or it was maybe that things were decreasing from left to right. But what the null is arguing is that there is no linear relationship, or in other words, that the slope is zero. So that as x is increasing, the y value really doesn't do anything. Right? It doesn't increase, it doesn't decrease, it just stays flat, like a horizontal line. What the alternative is going to argue is that no, it's not zero. So that whenever you see your x value increasing, we see the y value doing something other than zero. And so that would look like, either that it's increasing, or as x is increasing, that your y value is decreasing. Right? One of those two things. Now, the reason why I say one of those two things is going to depend on the context. So if we did an example about like how many hours that you study, then it would be hopefully that your grade is going to be increasing. Okay. But in general, the alternative is arguing that, yeah, it's not going to be like that. It's not going to stay flat where nothing's changing. It's either things are going to be getting better or things are going to be getting worse. And so in general, it's saying that there is a linear relationship or association. And specifically, what it's targeting is the slope. That this slope right here is not going to be zero, either positive or negative. Now, in the example we're looking at, the two variables that they're seeing if they're connected to each other is the number of classes that a student might miss. So, in other words, like they're absent, depending on their depression score. Now, just take a moment for yourself and think, like, do you think there's a relationship between these? that if somebody is more or less depressed, that might impact how often that they miss classes. So imagine if they're feeling like really down and out, maybe they don't want to go to class, right? Now, what they did is they collected data from students, and the two things were one, depression score, second, if they were ever absent from class. It was actually for 253 college students. And when they did this, these are the results that they got from a statistical software, right? And we're just going to call it the output. Now, usually what you'll do is you'll take your variables, like your ordered pairs for like each of the students, their depression score, how many classes they missed, and you would put all that in for all of the students into software. There's several of them out there, things like SPSS, RStudio. So you put it in there, and it will create the regression equation for you, which is right there. Classes missed can be predicted. And remember, one of the things that we used to do is put a little hat on our Y value that we're trying to predict. And then over here would be where you would input somebody's depression score, and then that would help you predict their classes missed. Now, part of the homework is going to ask you simply like, what's the regression equation? So it would be that I was just putting the parentheses around the little hat on. Classes missed. Again, these are the equation we're going to use to predict classes missed. It's got an intercept of 1.78 and it has a slope of 0.831. And the explanatory variable is somebody's depression score. It says, now let's again, some of what we do right now is going to feel like just very familiar because we've done it in 2.6. It's been a little while, but it says find the predicted missed classes for an individual with a depression score of 7. So we're going to take that 7 and we're going to plug it into the equation, and we'll keep one decimal place. So in your calculator, you would put 1.78 plus 0.0831. And if they have a depression score of 7, put that in, see what you get. And you should get 2.4 missed classes. All right. So, and again, just a real quick little recall of like how we use the regression equation. And again, usually we often rely on software to help us create the equation, the slope, the intercept. Now, another recall, when we are asked to interpret a slope, remember the little trick that I mentioned back in 2.6 is if you take the slope, which is the coefficient in front of the input, and you put it over 1 tells us sort of like the pattern, like for every one or each additional increase in someone's depression score, every time that goes up by 1, the number of missed classes might go up by 0.831. And that's it, right? Just a quick little recall. Like if we're interpreting the slope, we would say for each increase in depression score, number of missed classes, and we'll say might, because this is most likely just an observational study, might increase by 0.0831. So it's not a direct relationship where every time that your depression score goes up 1, that you're going to miss 1 class. It will take the depression score going up several times before it actually equates to a complete additional class being missed. But the main thing is that it's suggesting the slope being positive is suggesting a positive relationship. that as depression score increases, the number of missed classes also tends to increase as well. Now, in 2.6, we didn't do any testing to see whether those slopes were flukes or not. And so now that we have done hypothesis tests, we're going to use a p-value to see whether the positive association is statistically significant. So what we'll do here for the last part says, what's the p-value for the test of the slope? So again, the slope is saying that there's a positive relationship. And if you see right here where the output is depression score, you see the slope, and you also see its p-value, which is 0.014. So 0.014 is the p-value. And was this a fluke? If we're using an alpha of 5%, we can reject the null hypothesis. In other words, no, it wasn't a fluke. There's a very small chance that it was a fluke. So we would say that result is significant. We can reject the null hypothesis, which would be saying that depression scores and number of missed classes are not associated. Meaning, if somebody's depression score might go up and up and up and up, and it's not going to have any impact on them ever missing class, which doesn't really make sense, right? Usually, that's something that we might anticipate happening. If somebody's not feeling well, they might not want to go to school. So we're going to reject the null hypothesis. The p-value gave us a statistically significant result, and we can say that there is enough evidence to suggest or to support a linear relationship. And this is what I want you to do. I don't want you to say that there's enough evidence that the slope is not zero. I want you to give like the context. There's enough evidence to suggest a linear relationship between, and then we'll mention both of the variables, between depression scores and number of missed classes. And this works. Now, more specifically, it would be, that there's a positive linear relationship. Right? But most likely, if they were to get a fresh batch of students, collect their depression scores, and also collect their absences, it probably once again show up showing that there's a positive relationship, that as somebody has a higher depression score, they're going to tend to miss more classes. All right, and that is it. That's your 9.1. Again, there's going to be a homework, and usually that's like the main focus. Do the homework, understand it, and the problem that shows up on the test will be very, very similar to what you see here. Almost exactly the same, where you're going to do, the equation, write a short interpretation of the slope, use the equation real quick to do a quick prediction, and then identify the p-value. And if it's significant, reject HO. There's enough evidence to argue that there is a linear relationship between the two variables. All right. Now, the last thing that we're going to do for this class is 10.1. And what I really believe is that now for some of us, this may be the last like statistics class that we ever do, but if anyone does find themselves maybe going on to another, a statistics 2, where you're getting even deeper into to things about statistics, most likely you're going to get into something like this, which is multiple regression. And so what's cool about multiple regression is the idea that instead of having one equation where it's just one slope, you can now build an equation that's got multiple predictors in it. So think back to chapter 1 when we were doing observational studies, and we said observational studies can't be used for doing cause and effect. Why? Because of confounding variables, right? If you're focusing on the impact of just one variable on a response variable, you can't say cause and effect, because there's a lot of other variables that might be influencing like why certain things are happening. Well, what we can do now is we can take, if we know that there's several variables that might be at play or influencing what you're trying to predict, you can now take all that information, put it into a statistical software, and it will generate for you an equation that now puts all of those variables in there. And it will also give you p values for each of them, all while all of them being considered, and kind of give you a ranking of like which of the variables stands out as being the most significant and which ones aren't. Now, for that reason, you're going to see not just one slope with a beta 1, but you'll see a second slope, a third slope. And truthfully, you can put as many as you want. Okay. Now, most researchers, whenever they're doing this, will maybe put, their top 5 or their top 6, try not to make it as noisy and busy. But now with I mean, it's possible that you could put infinitely many variables in there. So let's take a look at our example here. And what I like about this example is, first of all, it's got 4 variables, and what's trying to be predicted here is GPA. There's the intercept, 2.37. But maybe GPA depends on how tall you are. Maybe GPA depends on how much TV you watch per week. And maybe it depends on how good of an SAT score you have. And maybe it depends on how many piercings you have. Now, this is an example that is presented or created by the authors of the textbook. But what I like about it is how it immediately for us, I think we start to get in a sense that, yeah, of all of these, like if you had to say which of these 4 predictors maybe actually makes the most sense, and that it's probably got the closest or most immediate relationship with GPA, and I think we're all going to say the SAT. But then I think what's cool about this is it does show you that you can really put anything that you want into a regression equation that's got multiple variables and see what happens. So, which of these do you think maybe is like, okay, that variable makes no sense? I can't ever imagine possibly that having some sort of impact, positive or negative, on your GPA. And you're either going to be saying one of two things. You're either going to be focusing on the piercings or the height. And yeah, but still, you still can do it. And I think that's part of like what this lesson is about, is you can put all kinds of variables in there. But then it's going to also give you a ranking of which of these is actually the most significant. And so if you look at the output here, now don't ever worry about constant. Constant is just the intercept, and it's always going to have a p-value of 0. But of the 4 that are being compared, over to the right, you can see each of their p-value. And maybe, as we might have guessed, SAT is the one variable of these 4 that makes the most sense, that academically it would have some sort of connection to your GPA being better. And you can see the p-value for it is 0.000, right? So in that way, you can think of it like as a ranking. Like that one having the best p-value is for sure the one that you want to kind of keep an eye on in terms of being able to predict how good somebody's GPA is going to be. But you can see the worst one is whoever's got the p-value of 0.451, which that's the piercings, right? And so although piercings is saying that for every piercing you get, your GPA is going to go up by 0.00840, like it's going to have your GPA go up, there's a 45% chance that that was just a fluke. So don't go and start getting a bunch of piercings just to see if your GPA goes up, because it's probably not. Now, what we're going to do with this equation, although some of these variables don't really make any sense, you can still use it, right? It's still useful as a way to predict somebody's GPA. And so what we're going to do is, suppose we had somebody who we knew was 71 inches tall, where you could plug that in for their height, and that they watched 1 hour of TV per week. You could plug that in for their TV, and that we knew that their SAT score was 1210. You could plug that in, and they had no piercings. So let's go ahead and do it, right? Let's start with the equation. The equation up here starts with 2.37. So you plug that into your calculator. Then you got minus 0.00983. Plug in your 71. Then you got a minus. So I'm moving on to TV. Now notice TV has a negative slope with it, which we'll talk about the TV just in a second. Let's go to finish part A. You've got a negative 0.00505, and we're going to plug in the 1 hour TV per week. Then we're going to move on to the SAT, which is the 0.00123. And suppose they've got a SAT of 1210. And then last, they've got no piercing, so 0.0084, plug in 0. So if anything, just take your time when you're plugging in each of these values into the regression equation, and you should get 3.16 GPA if we knew those four values for a particular individual. Yeah, and that's how you use it, right? But again, it's really cool because now if you're building one of these equations, you can put more variables in, and it'll also at the same time rank which variables seem to be most significant and which ones aren't. Now on the homework test, like you'll be asked to do an interpretation of one of the variables, and for part B, they want us to do TV. So again, remember the little trick is we could put that over 1. And so for each additional hour of TV that someone does per week, is it going to help or hurt their GPA? Well, it's going to hurt it, right? Because of the negative sign. Your GPA is going to go down, which I hope kind of makes sense. Yeah, I mean, if someone is maybe spending too much time being distracted by the TV, maybe they're less often studying. So for each increase in TV per week, somebody's GPA might, again, because of the slope being negative, we're going to use the word decrease by 0.00505 points. So in other words, there being a negative association. And the p-value for that one, however, there is 0.165. So maybe not, it's not significant. So that may have just possibly been a fluke. Now, the last little bit, right? And then we are done with lectures for this class. Um, C says how much variability in GPA can be explained by the current model. So think of like the four variables that were selected as being potential factors in predicting GPA. How good of those, how good of a model is this? And so the way that I like to explain this is there is a value known as R squared. And anytime that R squared is at least a 60%, it's considered a pretty good model. Like you found something that maybe got a good, it aligns pretty well with the thing that you're trying to predict. And where that comes from, I want you to just think for a moment back to 2.5 when we were doing correlation. And remember, correlation went from 0 in the center, -1 to 1. And actually, -1 to 1 was as far out as correlation goes. And anything like -5 was like moderate, excuse me, 0.5. And then something like positive 0.5 would also be considered moderate. And something like zero point 0.3 or -0.3 was like weak. Then we had zero point 0.8 that was like strong. So what they're saying is anything that's got a correlation or a an R squared of like 0.6 would be pretty good. And I want to just match that up with correlation, like zero point 0.5, zero point 0.6. That's like moderate, like a pretty good um, strength wise correlation. And then zero point 0.8, zero point 0.9 is like really strong. So zero point 0.6 or 60% is a pretty good like strength wise set of variables that are have a pretty good ability to predict or align pretty well with what you're trying to predict. But look at this. Here's the R squared value. It's 15.8%. So would that be considered a pretty good score for how good of a model this is or how good of a job it's going to do at predicting GPA? No, that's really, really weak, right? So 15.8% is the short answer for how much variability is explained by those four variables, which means it could be improved very, very much. So, what I want you to think about is if we've got like these four variables and we need to fix it, like who would we get rid of? Who seems to have like no significance towards GPA? Like we would get rid of the piercings first, right? And then maybe afterwards we get rid of the TV, and then maybe we get rid of height. But we'd for sure want to keep SAT. Now, what they're going to ask you to do is not so much like who you're going to get rid of, but if you were to add some new variables that maybe are better than piercings or better than TV at predicting GPA, because you can imagine them having a much closer relationship with GPA, like what would you put in? And that's all you're going to do for anytime you're doing one of these assignments or these problems related to 10.1. It's just come up with something just from your everyday thinking. Like, what do you think that hasn't already been mentioned in this scenario that might be something that's valuable in terms of being able to predict your GPA for better, for worse? Something that you feel like if you knew that thing or you collected that from individuals, it might explain why someone's GPA is going up, or it might help explain why it's going down. Usually, whenever I ask students to give me some examples, they might say stuff like, um, hours of sleep or hours of study. And both of those would, like, for sure, the hours of study, like, the more hours that you study, probably going to have a positive slope, maybe a pretty good p value with it. Hours of sleep, the more hours of sleep, like, maybe the more you're rested, might also be a reason why you do well in class and have a pretty good GPA. And those are only two. I mean, you can put lots, like 1,001 answers for this. But you could also put things that might hurt your GPA. It could be something like, hours of work. I imagine sometimes if a student's working like 40 hours a week, 50 hours a week, I've had some students tell me they're working like 55 to 60 hours a week. Maybe their GPA goes down just from being burnt out or being overwhelmed. So you can come up with stuff that's either got a positive or negative relationship. And again, just using what you notice from like everyday life. And then the last thing we're going to do here is of the four variables, which is the most significant? That would be SAT. And if you want to put a little note, why? Because it has the smallest p value. Which one is least significant? That would be piercings. And if you want to put a little reason as to why, because it's got the largest p value. And again, it'd probably be the first thing that we get rid of and replace with something else. But that is it. That is your last lecture that you need for the class. Hope it helps. And let's get this done and let's get test four done. And it's been a pleasure working with you. Take care.